Okay, so we're getting started with chapter 2 today. But there was two things I wanted to mention before we get started. Um, One is on Friday, I had to drop two students because they hadn't shown up yet. And so these are people that they registered, maybe it was three. They registered for the class, but then they never made it to WAMAP. And so if for some reason you're in this awkward position, what you need to do is contact me and we can fix things. Also, I noticed there were a few people that didn't get their homework started. And so there's a few sections that aren't done. And so I thought when the class is over, what I'd like to do is talk to people individually. I can even, talk to you privately. And so we can settle whatever needs to be settled so you get back on track. So that's what I want to know. Just if something's not quite right, just let me know right away so we can handle it early on. The other thing is, I just wanted to make sure you knew this. If there's ever a reason I have to cancel a class, what I'll do is try to do two things. I'll put it on the XYZ website. And then I'll try to put it on the calendar so that you can clearly see I had to cancel a class. So I just wanted you to know, I would try to send an email or do various things so that you knew that was what was happening. But I just want you to be aware, if that happened, look for the information on XYZ, and I'll try to have it right at the front so you can see what happened. And then I'll give instructions about what you need to do to go ahead. So that's all about that. So what I think I'm going to do, I'm going to go over here. So there's definitely, we're definitely getting ready to do 2.1. And so that's what I wanted to get started. And there's definitely fractions. And so I'm going to just, I'm going to start with really basic. So many times the fraction is written like this with the fraction line. And so I would read it as 3 divided by 4 or 3/4. The key thing to remember is this bottom number is the total. So it's a total of 4 spots or 4 sections. And what we have is 3. And so they do all kinds of ways, to show it to you visually. So if this was a full thing, we actually have 3, but in total there were 4, but we have 3 of them. And they call this top number the numerator, and this one the denominator. And so I don't know if you want to memorize this. I see the word denominator used more often, but numerator is first, denominator is second. And so we'll see that. You can put this on your list of definitions if you have a list, but that's what I wanted you to know. Now, the book talks about fractions that look like this. So I would call this a simple fraction, but the book calls it proper. I don't know why they like that word, but by the book's definition, a proper fraction is where the numerator is smaller than the denominator. So this is an indication that you have less than 1. So as long as the numerator is smaller, you've got less than 1. So, you have a fractional part of something. On the other hand, so book is calling it proper. I don't know what's proper. But then they go ahead and give you this, and they're labeling it improper fraction. Now, when this happens, the numerator is larger. This is an indication that you have more than one. So you have, in this case, you have one and a smaller fraction to it. Now, what I want you to know is people were taught, oh, improper, terrible thing. But the truth in algebra, when you have this is considered very good form in algebra. So this is a good thing. So I kind of hate the word improper to it because this is a good form. But I think at the very beginning, you're taught to turn this into a mixed number. And so when you have 5 divided by 3, that means that everything is in thirds. So I'm going to just take each one of these and make it into 3 pieces. And so I have this many, 1, 2, 3, 4, 5. Everything's in thirds. All the pieces are in thirds, and I've got 5 of them. Now it's very clear that I now have a full 1 unit and a fractional part. In fact, if you can see, this is a full one, so I'm going to call it 1. And this is a fractional part, and it's 2 out of 3, where 3 was the total in this piece. And so this actually leads us into what we do with a mixed improper fraction, so-called. 5 divided by 3, the computation is 3 divided into 5 is 1. And there's 2 left over. So the 2 left over goes like that. So literally 3 divided into 5 is 1, because you have the full 1, but then you had some remainder here, and it's 2/3. And so this, when you're asked to take this improper fraction and turn it into a mixed number, and it's mixed because we have a whole number part and a fractional part mixed. So that's what we're asking you to do. So let's see. They talk about equivalent fractions. And so I like to relate it to food sometimes. So if you had something and somebody said, okay, here's a nice little pie, and what you can have, your share is 1/2. And so this is another way to represent the total. And so it's in 2 pieces and you're given 1. Now, let's say I took the same pie and I divided it into 4 pieces. Now, are you going to be upset if I give you 2 out of the 4? Or if I give you 1 out of the 2? Is it the same amount of pie? I mean, you might like the look of this better, or maybe you like the look of this better. I don't know. But these are equivalent. And so we can say that 1/2 and 2/4 are the same thing. And I could change this. I could have 8 pieces total. Let's say I wanted to carve this up even more. But then if you wanted your share, it would be 4. 4 pieces out of 8. These are all equivalent. And so there's a real easy way to get from one to the other to the other. So I'm going to start with 1/2, and I want it to go to 4/8. The way it's shown is that to get from 2 to 8, I need a 4. And once I multiply the denominator by 4, I'm going to have to multiply the numerator by 4. So let's see, 1 times 4 is 4, 2 times 4 is 8. So this, if you look at this fraction here, we talked about it last class, 4 divided by 4 is really 1, right? So when you multiply some number by 1, you really get the same number. So this number is equivalent to that number. We didn't really change it by multiplying by 1. We just made an equivalent fraction. And so this little gimmick is something we'll use, and this carries over into other courses, multiplying the same number for the numerator as the denominator. And then we can say with confidence that this is equal to that. Now, I picked the simplest problem I could find, but this is equivalent. Now, okay. Now, of course, you know what the book does. The book will do it in letters. I don't know. Something like that. And so this sort of leads to confusion because like, what's that number? What's that number? What's that number? What's that number? Well, the only thing I'm very certain about is that this number and this number, because I use the same letter, are the same number. So this would be A times C, and this would be B times C. Okay? Or since they're both letters, you know, we're allowed to do this without the dot because this would be understood to be multiply. But maybe you like the concrete example better. And I think most people do when they're learning. And so this is 3/4, and I'm multiplying by what amounts to 1. So I'm going to get an equivalent fraction. 3 times 5 is 15. 4 times 5 is 20. So what I'm saying is 3/4 and 15 over 20, or 15 divided by 20, are equivalent because of what I did to them. These are operations. I multiplied by what equals 1. And so I have confidence that these are equal. Any question? Okay. The reverse of what I just did looks like this. If I have a fraction like this, it is possible to get an equivalent fraction, but reduced. And so what I'm seeing with a 10 and a 12 is a 2. I see a 2 right there. And so I'm going to do this, and this is how they showed it. I decided to divide both the 10 and the 2 by the same number. If I do that, I'm good to go. So 10 divided by 2 is 5, and 12 divided by 2 is 6. So what I'm saying is these two, the 10 divided by 12 and the 5 divided by 6, is equivalent. So you can take a larger fraction with larger numbers and reduce it down, or you can take a smaller fraction and build it up, but still be equivalent. And so we have to do both of those things when we work with fractions. Okay. Now, let me see. I want to do this one because I love this number. Let me see if I can find it. I'll make it up. One of the things you have to do is reduce fractions. And so this one can be reduced. And I use this example because this number here looks like absolutely nothing divides it. Okay? Unless you know something, very clever, it looks like nothing divides it. But the truth of the matter is this one divides by 3. And I'll continue to mention this little trick, but when you take a number like 51, which looks like it's worthless, and if you add the numbers 5 and 1 is 6, if 3 divides that, then 3 will divide into 51. And so you know what they did when they taught you, they never went this far. They never pushed you into like, what are you going to do with 51? I have no idea. Well, there's tricks. And the trick, let me show you 51. I'm going to divide it. 3 into 5, right, is 1. 1 times 3 is 3. How many left over? 5 take away 3 is 2. And you bring down the 1. 3 into 21. And we'll do more of this division, but I hope that some of you know this. 7 times 3 is 21. What does that mean? That means that 51 can be divided by 3. So I'm going to divide this one by 3, and I'm going to divide this one by 3. And what we're trying to do is realize that we don't have a ceiling where we can only do the easy ones. We can sometimes do harder problems because we understand about numbers. So 6 divided by 3 is actually 2. 51 divided by 3, according to this, is what? Right? Because there was no remainder here, so that was a perfect answer. 3 times 17 is 51. This was the answer. And I'll keep mentioning this about the 3s because they're so helpful, this little thing, because numbers hide and you can't see what to do with them. Notice this problem here. These were both even. The last digit, the last number was 0, and the last one was 2. That meant that we can divide it by 2. Right? Because when they're both even, we can divide by 2. When they both dividing by 3, this is 6, and it's pretty easy to see that 3 divides it. But 5 plus 1 is 6. And it didn't have to be the same number. It just has to be divisible by 3. That's a trick. Let me do another one to show where I'm headed. Since both of these have a 5 on the end of them, we know that we can divide by 5. So I'll take this 15 divided by 5 and this 35 divided by 5, and let's see what we get. 15 divided by 5 is 3. 35 divided by 5 is 7. The same would have been true if the last number had been a 5 or a 0. That's still saying 5 would be a good choice. Now, many times they tell you what to use, but what happens when they don't? Then you have to have an understanding that 5 would be an excellent choice. Let's give it a shot. Let's give it a shot. And I chose it because the 5 and the 0. So 25 divided by 5 is 5. 40 divided by 5 is 8. What I have is the equivalent fraction in reduced form. And here's the deal. Every time you get an answer and you're about to turn it in, this is my answer. There's this unwritten rule that the best answer is the simplest answer. And the simplest answer is, in most cases, the reduced answer, unless they want the other way. And they tell you so. So instead of turning out 25 divided by 40, they would be expecting you to give the answer 5 divided by 8. Does that work for you? Here's another example of what's the simplest. If you had the number 6 divided by 6, now we had this last class. 6 divided by 6 is actually 1. Now you tell me which is simpler. They don't like mess. They like simple. Do you buy it? The other example of the simplest is the best, and it's so obvious that it's like they almost miss it telling you this, and we don't like that. 7 divided by 1 is a perfectly acceptable answer, and yet there's a simpler version. They don't want messy answers. They want the nicest, sweetest answer that's out there. And so that's that's like an unwritten math understanding. And so we need to understand it and provide the simplest version. Sometimes they'll tell you, give your answer in reduced form. Well, that's really saying simplify it. Go for the simple version. But that's what I wanted you to see. Now, I found a couple of questions where they had fractions like this. Let me see, this is good enough. And what they said was, which is the smallest, which is the medium one, and which is the largest? They may not be in order. And so it may not be possible to tell which is the bigger one, which is the smallest one, which is the middle one, because you can't really compare it. It's like apples to oranges. You can't really do a good job of comparing it. So here's the instructions they give with this problem. Write each fraction as an equivalent fraction with the denominator 24. I abbreviated. So each one would be written as a denominator 24. So I would have to take 5/8 and turn it into 24s. Okay, I would have to take 5/6 and 3/4. All of them. Now, why did they tell you 24? Because every last one of these can be converted to 24. So it was a very good choice, but they did tell you what to use. Eventually, you'll have to figure it out. So 8 needs to be 24. So this is a wannabe 8 that wants to be 24. So here's what we do. What number would do it? And I'll talk to Charles in a minute. We would need 8 times 3 is 24. And once I pick that number, I have to pick that. Charles?
So you always use the denominator. You can't use the numerator for that, right?
Well, they specifically in the instructions said the denominator will be 24.
Okay.
And so literally we had this piece and we had this piece. This was the missing piece. And so we had to supply that first to guarantee we would get the 24 as required. And then once that's determined, then this is the same number. So these two have to be a match. Why? Because 3 divided by 3 is 1. It won't be equivalent if you don't do same and same. Fair is fair. Multiply by 3, multiply by 3.
Okay.
No getting creative here. So 5 times 3 is 15. How's that? Let's try another one. I'm going to try 5/6. And what I need to do is turn it into 24s. I left room here on purpose because there is a number that will bring this up to 24. What's our number? 6 times what?
4.
4 it is. So this is 4, which means this is 4. So this is what I'm doing. 6 times 4 is 24, good. 5 times 4 is 20. So already I can see that this one's bigger than that, right? But I have one more to do, and I'm going to do 3/4. And this, so I have to be 24. I had to use the 3/4. I'm going to bring it up to higher terms. And so what number? 4, I just said it. 4 times what is 24? You know what?
6.
6. And what's there is there. So 4 times 6, 24. Good job. 3 times 6, 18. Why is this version better than the original? Because now we can see which is the biggest, which is the smallest, and which is the middle one. because we're all working at a circle or a thing where everything was divided into 24 pieces. And this one has only 15, this one has 18, and this one has 20. And so this is practice for when we're going to be adding and subtracting fractions, but we want to see, could we do it knowing that 24 was what we had to aim at on all three cases? Any question? So the way you would then write it, of course, knowing that's the case, the smallest one would have been 15 over 24. The middle one would be 18 over 24. And the biggest would be 20 over 24. Right? Small, medium, large. Now they used a symbol here in the book, and I assume in your reading. And the symbol, there's two of them. Do you know which is which and how to read it? One of them is greater than, one of them is less than.
Everything on the side of the point is smaller and everything on the side of the other two is the bigger.
Is that how you learned it with the alligator? No.
Mouth.
No. So the smaller point has the smaller number?
That's what I
That is
thought.
correct. I'm going to expand on this, but this is going to the smaller one, this is going to the larger one. That will work. When you compare these two, this is smaller, and so you would use this symbol. You would use it like that as well. Now you could then take this result and 15, let me see, 15 over 24 actually was the 5/8 if I look back. And 18 over 24 was the 3/4. And 20, this was the 5/6. I don't think you could see it very well in this original form. This was the 5/8, this was the 3/4, that was the 5/6. I don't think you could see it, but in this form, you can clearly see it. I want to talk about less than and greater than, because I believe we've got a simpler way. I'm going to draw this big. Okay. Now, the magic of technology. What letter is that? It's an L for less than. Got it? Can you see it now, even in the correct? This one is less than. Well, if that's the case, then this one is greater than. Now, I know people, different places have different ways of writing numbers. And so some people have this left and right problem because of that. And so this is an issue, but what we're doing is if I had a number line, the reason we write it this way is because this is the way we read in English. This, and then go higher, and then go higher. So going to the right is going higher. So this is the symbol. Going that away is greater. But you have to accept this number line. Whereas going this direction is going lower on this number line. Okay? Now I accept the fact there's a confusion if you learn things the other way, but this is how to relate it. So this is going down, this is going up. Why did there's no left or right. It really didn't matter, but what they did was they put this together based on how we read in English. So here's your book. I have a Kindle or something. And so you're reading this way. So that's getting more and more and more. Whereas if I go back, less and less and less. And so this is greater than, this is less than. I hope you see that L, because there it is right in your face. So once you have the L for less than, the other one's the other way. Do you like it or not? Okay. All righty. So that's the first, how's our time? Okay, that's our first section. Oh, here was the problem. See, the book likes 51 as well as I do, because it's a kind of number that people think nobody divides 51. But now we know better, don't we? And so this divides by 3 as well. Can you see it? Because 2 reasons, you could divide this by 3 and you could divide that by 3, but also 3 and 9 is 12, which divides by 3. And so this will divide by 3 as well. Now, some of the problems they ask you to do is say, okay, divide the numerator and denominator by 3. So they actually told you what to do. They said divide by 3, would you? But you can see now that that's actually, not only did they ask you to do it, but it was a good choice. So 39 divided by 3, if you ever can't see it, just scribble on the side and keep it neat so that you don't get tangled. But it is 3 into 3 is once, 3 into 9 is 3. And so it's actually 13. And 51 divided by 3, do you remember what it was?
17.
It was 17. Now, does this going to reduce any further? No. These numbers are special. And in the next section, in section, 2.3, we talk about why these numbers are special. They just don't divide down anymore. And so, but anyway, this would have been your answer. But they told you to divide by 3, so you had to turn this in as your answer, even if it would go further, but I don't think it will. Let me see about this one. Here's reverse, and then I'm going to move on. This was a problem where they say the instructions, write each as an equivalent fraction with a denominator 6. Denominator, remember, is the bottom number. They're asking, can you write it with 6 as the denominator? And so that's the reason to remember the word denominator. And so somehow I have to figure out, what does it take to get this to 6? Well, since multiplication and division are opposites and tied to each other, we could actually figure out what to divide by. Let me take 6 into 78. 6 goes into 7 once. This is 6. 1 left over, 18. 6 goes into 18 3 times. So the truth of the matter is, to get 78 down to 6, we actually had to divide by 13. Again, 13 is a special number, we'll say that. So if it took dividing by 13 on the 78, we're forced to divide by 13 on the 65. Okay, I can do that. 13 into 65. Well, the 5 is making me wonder. I see a 5 and what do I think? I think 5, maybe. I'm going to try 5. I'm a good guesser, by the way, but still I saw the 5 and that's what clued me in. I'm going to try 5. 5 times 3 is 15. 5 times 1 is 5 and 1 is 6. Aha.
Oh.
So 65 divided by 13 is 5. Okay, what I want to do is give a little bit of a harder problem, although most of the problems you're asked to do are not this difficult. But this is basically, do you have the large fraction that needs to be reduced down? Or do you have the smaller fraction that needs to be raised up? And so this is back and forth. Either when it's small, you multiply to get it higher. When it's large and needs to reduce down, you divide by something, even if it's something stupid like a 13. Okay, and maybe there's better problems. I might have pushed my luck there. Okay. This is just a cute little question. 1/5, 1/10, 1/20. Which is the biggest number? Anybody want to volunteer? Somebody just came back. I'll take a minute.
5th is the biggest.
Which one?
1/5.
It is. Because we have only divided by 5 and we have one of them. When we divide things into 20 parts, remember the pie? And we only get one little piece out of 20, it's not much. So this is the biggest, this is the medium one, and this is the smallest. And so don't be confused that because the bottom number, actually, when you're dividing by a larger number, you tend to get smaller. Okay. Now, the next section, any questions? This is a mixed number according to the book, and we'll just accept it. What they might ask you to do is take that mixed number and make it a fraction. Now, the instructions might say, make it an improper fraction, but it's making it a fraction. Mixed number means there's a whole number and a fraction. And so the question is, what's the easiest way to do it? Well, you probably learned to do this, but I'm going to show you how I do it. 8 times 2.
19.
16.
16.
Add 1. And you get 17 divided by 8. Let me do 1 1/3. 3 times 1 is 3, plus 1, the plus is here, is 4/3. Now you need to have confidence that this little way to do it is going to work. So here's 1 1/3. Remember I did this little picture before, I think. So I have, that's a whole 1 and that's a whole 1. So if I have 1 1/3, I have all of the first one and 1 of the second one. Everything's been divided into 3 equal parts for each item. And so literally I have 1 1/3. But if you look to see how many I actually have, 1, 2, 3, 4, I actually have 4/3. How did I get it? Well, I didn't have to draw pictures unless you like pictures. I actually like pictures because sometimes that's where it actually, works for you. 3 times 1 is 3. That got me this much. Plus the 1 more is 4, and always over the same denominator, 3. How's that? Can you do it? Oh yeah, they said make it an improper fraction. Doggone them. So the instructions would be, make this mixed number an improper fraction. So you say, all right, I will. So this number times this number is multiply. Then we're going to add the 5. So 6 times 9. You have it on your head? It's 54. And the cute thing about problems that multiplied by 9, they all add to 9. I don't know if you've realized that. People study these little patterns in numbers, but when you multiply by 9 and it's under 100, the numbers always add to 9. So one way to remember this could be one that you've forgotten. If it had been 6 times 10, it's not, but let's pretend it was, it would have been 60. But 6 times 9 is smaller, not quite as much. So it's not 60 something, it's 50 something. But what number would you put to make it add to 9? Well, you'd put in a 4. So it's 54 plus the 5 that's right here, which is 59. So it's 59 divided by the denominator 9. So I know what happens. People forget their multiplication, or they never learn them, or whatever. But I'll tell you what, if you can bring them back into your memory, it will make it life simpler. Does anybody have some one multiplication fact that they can't remember? They always can't remember a certain one. I know which ones are the worst.
7.
7. Here's one of the ones that a lot of students have trouble with. Anybody know it?
56.
You got it. I want to write this in reverse. Five, 6, 7, 8. Darn, isn't that sweet?
I like it.
You like it? The thing about 9s, I want you to see this because this is so good. 9 times 3 is less than 30, so it's 27. 9 times 4 is less than 40, so it's 36.
The 9s are like the easiest ones.
It's not 50, it's 45. Do you see what's happening? 9 times 8 is not 80, it's 72. So there.
But the 9s are the easiest ones.
Huh?
The 9s are the easiest multiples.
The 9s are easy. If you can get the idea that it's not 10 times that, it's not 30 in this case. It's not 30, it's 20 something. It has to be 7. And so the other thing is they all add under 100, they all add. The truth of the matter is any number even larger that divides by 9 will add to a multiple of 9. So there's all kinds of gimmicks, like the 3 and the 9 have cute little tricks. 5 has cute little tricks. 2, dividing by 2, they're all even. You know, there's actually tricks for 7, but it's so hard nobody could remember it. So, but there are tricks. Somebody figured it out and proud of themselves.
They have a trick with your hand you can do with your 9s.
What now? Oh, I know. I never learned that one very well because I was pretty happy with my other one. But yeah, there is definitely. Okay. Let me get to the right section. Okay, I think it's our time. So somebody had a question from 2.1. Is that person still here? Honestly, You probably don't hear it, but I hear it when people leave the meeting. I can't always see who it is. But so I don't know if they're still here, the one that asked for 2.1. Did we cover it? Well, see what I'm seeing. Let's see. Okay, I think that's it. Let me. Sometimes I don't see chat in time, and so if I don't, graphing the number, okay. All right. That's what I was trying to remember. It was graphing the number on the number line. I can make up a problem for you. Let me see. So let's just make it up. Here's a third. Here's 5/6. Here's 4/3. It's going to start with 0. And so if you had to find the right point for 1/3, you would look to see where 1 is. And let's say you can spot this. So from 0 to 1 would be 1, 2, 3 marks. And so 1/3 would be at the first mark. This would be 2/3. And so this would be our 1/3. Okay. Now, if they had 5 out of 6 or 5/6, then the mark, they had to be divided into 3 equal parts. So 1, 2, 3, 4, 5, 6. So you have to look for the marks that break it up into 6 equal parts, and you would pick this spot right here. Cassidy?
When do you mark? So when you do 1/3, the one that you did before, the 1/3, why do you mark the one look like it's behind the third?
Well, this is the 5/6. Let me tell me where 1/3 would be. I'm not sure I got your question.
On the third mark, that would be you one, right?
Almost got it. If this is marked into 6 pieces, 1, 2, 3, 4, 5, 6, and so I counted them to be sure, and I had to find the fraction 1/3, but it's in 6. This is where we're using some of these little things we just figured out. I have 3 times 2 is 6. 1 times 2 is 2. So when it's marked in 6, I have to take the second one over. Because
Okay, thank you.
you got it? And then the last one, the last one is 4/3. So I made such a mess here. Let's see. Okay. Here's 0, here's 1, here's 2. 4/3 is more than 1, right? 4/3. It's that improper fraction that they call it. So 4 divided by 3 would be 1, and there's 1 left over. I think we've done this enough times to see that. And so you have to be over in here somewhere. So here's getting 1. I didn't quite make this proportional. And so what you would then do is look to figure out where 1/3 would be. Now, if it's marked in 3 pieces, you would be here. But if it's marked 1, 2, 3, 4, 5, 6. 1/3 would have to be 2 out of 6. So it would be here. So that's what we just did. We multiplied this by 2, we multiplied this by 2. So when it's divided into 6 pieces, and you're going to get 1/3 of the pie, you want 2 out of 6. I taught my son division with cupcakes when he was little. There were 12 cupcakes and there was 3 of us in the family. Doggone if kids don't get that pretty quick. Right? You understand what I'm saying? No problem. Okay? And this is what we're doing. We're playing with fractions. Nobody was going to get 12 cupcakes. So the question was, how many do you get? Okay, same thing, it's just food, if you like food.
That was my original question. Like when the diagram that you just had up before. So I'm looking at you with you had the 1 hole, and when you do the third or the 1/3, you put it behind the 1. And if you just have a fraction of like you had before the 1/3, you put it before the 1.
Yes, so
Okay.
so anything that's under 1 would have to be here somewhere. And everything like our 4/3, we now know that that's clearly 1 1/3. That's more than 1. It's 1 plus, so it's got to be in this section.
Okay, that was my original question. That's what I was asking.
Oh, okay, well,
see
that's good. I think we covered some other things that probably helped too, but thank you for a question. It's good. Okay, there was a definite chat. Let me see. I have trouble. Sometimes I can't. Oh. Okay. I figured out. First, I figure out how to do Zoom, and then they change it on me. And so I'm always trying to figure out what's their newest little gimmick, or maybe I never learned it before, but I just figured something out. Okay, what do we say? Any questions? So it's what I want to do, I think, is stop.